Quadratic inequalities. So quadratic inequalities are the quadratic expressions ax square plus bx plus c with the quadratic inequality which can be greater than 0, or we can say that we have the quadratic inequality so that the quadratic equation ax square plus bx plus c is less than 0. So for these quadratic equations for inequalities greater than 0 or less than 0, the coefficient of x square, a being a positive, I can say that the coefficient of x square being a positive, my quadratic curve is with a minimum turning point, and in this case I have the x-axis intersecting the curve at 2 points. Now let's say that the 2 points here, they are S and T. The two x-intercepts are S and T. So if I say that this quadratic equation is greater than 0, then it means we are talking about all the x values which needs to be bounded by the curve and the x-axis, and they need to be greater than 0, meaning all the y values for the curve, they have to be positive and therefore above the x-axis, and this is the region then that we shall be talking about. So with this curve, what I come to know is that the inequality is for x to be less than s, or we can say it's x to be greater than t. So x to be less than x, this is the range of values of s that we have, and greater than t, this is the range of values of x that we can have for this region. On the opposite side, if it says that the quadratic inequality ax square plus bx plus c is less than 0, then for this to be less than 0, we are talking about the curve and the set of values of x. Now let's call them as p and q. Set of values of x less than 0, meaning all the y values, they need to be negative and therefore they should all be below the x-axis. So bounded by the curve and the x-axis, all the values of x are now below the region, below the x-axis. Therefore, in this case, I can say that the set of values of x is p less than x less than q. So always remember, whenever our quadratic expression is greater than 0, then with respect to the roots of the equation, I am going to have a discontinuous range. I'm going to have a discontinuous range. Whereas if it is less than 0, here, then I can say that my range is continuous starting from P to Q. So this is what the introduction of quadratic inequalities is. So let's start with the questions to understand it more. Solve the inequality x plus 2 bracket x minus 5 bracket lesser or equal to 0. Now the first thing that I need to check here is the coefficient of x square. I can see that if I multiply x by x, then I should be having here a positive coefficient of x square, which is Na, telling me that the curve that I shall be having is going to have a minimum turning point. The next thing is this equation that is given, it's already factorized, so I can say that the two x-intercepts are negative 2, or we can say it's a 5. Therefore, I can have the x-axis here with the two roots as negative 2 and a 5. So with the inequality which says it is less than 0, I know that the region bounded here is to be the region below the x-axis, so that I can have a continuous range, and I can say that the set of values of x confirming this inequality is negative 2 less than x, which is lesser or equal to 5. So this shall then be my answer. Let's solve another question. Solve x square minus x minus 30 to be less than 0. So again, a quadratic expression there, which needs to be less than 0. I can see that the coefficient of x squared is a positive. I can have a minimum turning point curve, and I can have the x-axis. The next thing that I need to do here is to find the x-intercepts, and to find the x-intercepts, I can get the factors of 30 as a negative 6x and a plus 5x minus 30 to be less than 0, and I can solve it further. So that I can say that it is x minus 6, x plus 5 to be less than 0, and the two x-intercepts that I have here are 6 and minus 5. The roots of the equation are negative 5 and 6. We are talking about the inequality which is less than 0, and for this to be less than 0, I need to make sure that the region lies below the x-axis. Therefore, the set of values of x confirming the inequality is negative 5 lesser or equal to x lesser or equal to 6. Now let's do another question to understand the topic more clearly. So here it's x squared minus 4 times x plus 6 greater than 21. First, bring it to the quadratic form, and from the right hand side, bring 21 on the left side so that the equation is greater than 0. And here I can say that my equation is x squared minus 4x minus 45 to be greater than 0. Again, I can see that the coefficient of x squared is a positive. Therefore, I should be having a curve with a minimum turning point, and then the next thing is to find the two x-intercepts. So to find the x-intercepts, factorize the equation, and you can say it is x squared plus 5x minus 9x minus 45 to be greater than 0. Solving it, it's x plus 5 minus 9 and x plus 5 again, or x plus 5 and x minus 9 greater than 0, or I can say that the two x-intercepts or the two roots are minus 5 and 9. So I can just make the two roots here, plot the two roots here. It's negative 5 and a 9. Again, what I see here is the inequality which says that the region has to be greater than 0. The region here, this needs to be greater than 0. So now the thing to understand here is the inequality which says it should be greater than 0, and we know that whenever we have the inequality which is greater than 0, we are talking about the region which lies above the x-axis. So above the x-axis meaning that my region has to be on the upper side of the x-axis here with all the positive values of y. Therefore, I should be having discontinuous range which should be less than negative 5 and greater than 9. So I can say that the set of inequalities for this quadratic equation is x less than minus 5 or x to be greater than 9. Now let's solve another example. Solve 16 minus 6x minus x squared to be less than 0. So rearranging this equation, I can say it's a minus x squared minus 6x plus 16 is less than 0. Now in this question, I have x squared with the negative sign, and I can solve it further so that I can take the negative common, and doing that, I can say that with x with negative taken common, I will be left here with x squared plus 6x and a minus 16 to be less than 0. Now here is the typical case that whenever we have taken out a negative common, just remember we have to change the sign of inequality here. This inequality, whenever we are solving it with the negative sign, always remember to change the sign of inequality to the opposite, so that if the question says it is less than 0, then I should be writing it as x squared plus 6x minus 16, which needs to be greater than 0. Now I have a simple quadratic equation with a minimum turning point and the x-axis. They are talking about the region to be greater than 0. Again, repeating, whenever we are taking out the negative common and solving 0 with that negative sign, please make sure that you have changed the sign of the inequality to the opposite. Like over here, it says it's less than 0, so I have changed it to greater than 0. Now just factorize the equation, and when I factorize the equation, I should be getting here x squared minus 2x plus 8x minus 16 to be greater than 0. X common, it's x minus 2 plus 8 common, x minus 2 greater than 0, or it is x minus 2 and x plus 8 to be greater than 0 here. So I have come to know that there are two values of the x-intercepts. One is a 2 and the other is a negative 8. Just plot them as a negative 8 and a 2. And now the region that we are talking about says it needs to be greater than 0, meaning we are talking about the region above the x-axis, greater than 0, above the x-axis. Therefore, we are talking about all the values of x which can be less than negative 8 or greater than 2. So here I can give the inequalities as x to be less than negative 8 or x to be greater than 2.